Hello guys, this is another tutorial from Codeworks. In this tutorial I am going to perform the coding of Heapsort. The basic theory of Heapsort has been discussed in the previous tutorial. In this tutorial I am going to implement it in C. For this I am going to use code blocks. You can use any editor you want. I am going to save this file as Heapsort 6.c. Heapsort is one of those tutorials which I had to practice quite some time to master it. So as you can see, I have made 5 files before. Now, those are my practice files. Okay, let's start it by including stdi.h and hash include stdio.h. Then let's make the Heapify function. This function would accept an array as a parameter and would uh, generate the heap data structure of that array and initialize it to the array. Okay, let's start. Void, it's void because it won't return any value. Oops. Void heapify, void heapify int array as the parameter, then int I, not I, n of number means number of elements in the array. Now int I, this is the loop counter for I equal to 0, I less than equal to number of items I plus plus. Actually it won't be 0, it will be 1 because I will start my searching from the level 1 of the tree. Let's assume level 0 has the root node and level 1 has the children of the root node. I will start from the children of the root node. We are going to see in a minute why. Okay, I am in another variable c. C will store the current value of I. Then I am going to initialize the do while condition, do while loop, do something while c is not equal to 0, means not the root node, while. Okay, and another variable root here and root equal to c minus 1 divided by 2. Okay, now c is a child and root is the parent of the child. Okay, now have to check something. I'm going to assume this is a max heap tree instead of parent node. I was saying the value of the root of the child should be more than the value of the child node. If this is not the case, I have to interchange it. So let's find if AR subscript root means if the value of the root node is greater than ARC. Now, this root is not the absolute root, this root is just the parent of the child node, the concerned child node. If it is greater than this, then no problem. Is less than, then the problems. Okay, also interchange it. Temp equal to AR subscript root. Okay, now AR subscript root is equal to ARC. Okay, and ARC is equal to temp. I have not initialized temp here. Let me do it here. comma 10th. Okay, it's initialized now. Do this, then as you can see here, it says while c is not equal to 0, so means c is not equal to the root node, means the absolute root node, absolute root of the tree. There is no concept of absolute root, just the root, but for the sake of understanding I am just saying it. While c is not the root of the tree, this thing will continue, this algorithm would continue, this function will keep on performing job. Now what I will do here, I have to initialize c to its parent, means now c is the parent of itself, c equal to root. Okay, uh, this will do. This is the Heapify function. Now let's uh, write a method to print the array. Void print again, yeah, not empty, because why, because it won't accept any argument. Oops, no, it's not that it won't accept any argument, it means it won't return any value. Int a as the argument and the number of elements I know. Okay, now and we counter for I equal to 0, I less than equal to no, I plus plus, then print the values, printed percentage d comma ar subscript I. Okay, okay, so my print function is also done. Now I will write the main function, void main. Again, no such thing as void main in code blocks, it's int main. So and return a value, return 0 suppose. Okay, then we need to find array of 5 elements, let's suppose equal to 5, 8, 7, 0, 1. Okay, now let's call the Heapify function. Heapify what? Heapify the array of size 5, means 4 will be sent here, because as you can see it's I equal to 1 up to no. Now when n equal to 5 means it's the 6th element in the array, it's not there, so up to 4, 0, 1, 2, 3, 4, so 4 here. Heapify, then print the function, print the array, print, okay, print, okay, print the array ar of again 4. Let's run it. Okay, this is my heap tree now. I'll show you the reason why it can do this. These are my numbers here. First 5 will be taken out, 5 will be inserted in the heap tree, so 5 becomes here like this. Suppose this is the node 5, then my next number is 8, so 8 will come here. It follows BST property, it follows complete binary tree property. The nodes get filled from left to right, 8, then 8. This is my next node, then my next node is 7, so 7 would come here. oops, sorry, sorry about this, but I missed a point actually. As you can see here, this number is 8 and this number is 5, and 5 is the parent of 8 and 5 is less than 8, so this can't be the case, so it has to be interchanged. This is what I was talking about. Now loop start from I equal to 1 because c equal to I and c equal to 1 now. Now this is the child node, this is the parent node. C minus 1 by 2. What does this mean? C is 1. 1 minus 1 by 2 means 0 by 2 means 0. Means the index of the parent node in the array is 0. Okay, now 8 is more than 5, so this interchange will take place. Let's interchange it. Okay, now this is 8 here and this is 5 here. Fine. Now let me remove these arrows. Okay, now my next number is 7. 7 would come here. 7 is less than 8, so no change required. My next number is 0. 0 will be filled here. 0. The next number is 1. As you can see, both these numbers 0 and 1 are less than 5, so no change required at all. Now let me draw the lines here for the clarity. These are the children of 8, these are the children of 5, and let's take this round color. Okay, now the index of the root node is 0. This node is this is 1, this is 2, this is 3, this is 4. Means if my array is here like this, 5 elements, 1 2 3 4 5. Okay, then 0th element would be populated by 8. First element means the first index will be populated by 5, then 7, then 0, then 1. So this is my array after sorted, after being heapified, not started heapified, and this was my array before being heapified. So as you can see, there is this change here, and this is the output which we have got from the program. Okay, let me show you the output again. It again. As you can see, this is the same output which you have got. Okay, so my heap function is done. Now, Heapify function is working. Now, what is heap sort? Now, heap sort, the objective of heap sort is we heapify the array, and the first element is either the smallest element or the biggest element. If it's a max heap, the first element is the biggest element. If it's a mean heap, the first element is the smallest element. Now, actually whenever I am pausing, I am actually thinking to myself what I'm going to say next, how I'm going to explain it properly. Now, first element, since it's a max heap, the first element is the biggest element, and what this heapify function does is it takes away the first element, puts it in an array, replaces the position of the first element with the smallest element, calls the heapify method to heapify the array again, and again okay, it's like the function heapify function is called once it find the max heap of the array. The first element, the root element, is the biggest element. It takes out the root element, puts it in the array, again heapifies the function. Now again 0 is the biggest element, it takes it out, puts it in the array, and again calls the heapify function. So this way every time So it takes out the biggest element every time and it puts it in a separate array and then heapifies the rest of the array. So this is what we are going to do now. Um, do I need another function? Let's think. No, we don't need a function, I guess. Or do I? The first element is going to be replaced by the um, last element. No, we don't need a function, I guess. Yeah. But I need a counter I. Okay, now for I equal to 0, I is less than equal to 4, I plus plus. Now this is called the Heapify function once. Heapify the AR and 4 is passed here as discussed in the discussed earlier. Now I need another array here to store the elements, comma AR again of size 5. Okay. Now AR I equal to no, ith element of A equal to excuse me ith element of A equal to 0th element of AR. Okay, this takes out this element. Then to replace and to delete the first element of the array of the okay, this is going to be 4 here. This will be 4 minus I. Okay, now to replace it with AR 0 equal to AR 4 minus I with the last element. Now why I'm doing 4 minus I, it's because once I delete the topmost element, the number of elements is going to be reduced by 1, and there are 5 elements and index starts from 0 to 4 means 5 elements, and if I take out one element, number of elements remaining is 4, so 0 to 3, so 4 minus I is the first case I is 0, so 4 minus 0 is 0. The next 4 minus I is 3, then 2, then 1, then 0. And in the first case, when I equal to 0, 4 minus 0 means 4. At the fourth position, there would be the smallest element, or rather the smaller of the elements, because it really doesn't confirm us that the last element will be the smallest element. Anyways, we replace it like this. But in the second case, when there is one less element, the second last position of the array will be populated by this smaller element, so 4 minus I. Okay, so this is my function. I think there's nothing more. Let's just print it. Print AR comma 4, not AR, this A comma 4. Let's see. Print printf function here. printf printf. Sorry, I'll just give a blank line here. It's like a tongue twister. That's why. Sorry for that. Let's print it. Doesn't matter. Let's see. Error redeclaration of int AR5. Okay, obviously this will be A, not AR5. Okay, as you can see, the array is sorted 87510. This is my sorted array. Let's beautify the code. Oops. Anyway, F2. Okay. Yeah. Print. Yeah, I don't need this anymore. Let's just say the sorted array is the sorted array is this. Yeah, it's giving correct result. 87510 is indeed the sorted array. Let's change the result. Let's change the numbers a bit. Let's say 15 here. Let's print it again, and it again gives the correct result 158750. As you can see here, it's a pretty short program, only 46 lines of code. If you understand it properly, it's pretty easy. I have seen blogs and other source code in internet. They are pretty big actually, pretty huge coding and very complex actually. They take structure and pointer and God knows what. Um, Maybe you may be comfortable with their coding style, but I faced some problems following their coding style, their solution. But I feel this is pretty easy, pretty clear. This is pretty obvious code actually. But for example, this portion is it just swaps code to swap. Root is this. This is the root. The root of the child. Root of the concerned child, and so on. Like it's pretty easy. This is a Heapify function. This is a print function. It's the array. Just Heapify it. Pull out the topmost data. Then delete that data. It's pretty easy actually. So I hope you liked it, and I suggest you to go through the other tutorials as well, because I have explained quite some of them, the linked list, the circular queue, DQ. Go through them, and also check out my searching and sorting algorithm tutorials. They're also pretty good. I have discussed. Uh, okay, I'm sorry. I'm sorry. It's like uh, I messed up. Actually, I was thinking Heapsort is a data structure. That's why. Yeah, Heap, Heapsort is a sorting method, and Heapify, it creates heap tree. And I was thinking of trees. That's why I was thinking of that those tutorials. Yeah, you check those tutorials as well. The circular queue, DQ, I've done that there, and also see the merge sort, heap sort. Okay, well, the time complexity of this heap sort is O n log n. It's pretty easy. It's pretty easy. Well, actually, yeah, I should say this. The complexity of this function is log n, and the complexity of this code is only n. So it's n log n into log n. It's like that. I'm not going to the details of how to derive that. Uh, if you're interested, you can always uh, search a book. I'm sure it's available somewhere. But here it is. It's pretty easy, pretty obvious, and it's enough for you to score good marks or learn C. And thank you so much. Do hit like and do subscribe for more videos. And yeah, if you have something to say, if you think I made some mistake or I could have modified better, do say so in the comments below. Thank you.